So same idea. In this one, we have an input of 4 pi over 3. Find w, the wrapping function, w stands for the wrapping function, of 4 pi over 3. The input is, you can look at it as a real number, 4 pi over 3, or you can look at it as an angle measure, 4 pi over 3. That's a little harder. Sometimes it's helpful to convert to degrees. I don't necessarily recommend this, but when you first start messing with radians. So if you think of the input as an angle, which you're free to do, how would you convert that to degrees? What would you multiply by? 180 over pi, right? It would be the correct conversion factor. And then, okay, pi's cancel. How many times does 3 go into 180? 60. What's 4 times 60? 240. So it's a 240 degree angle. Can I show you a better way to locate it? To locate the angle without converting? Here's a better way. Angle-wise, 0 degrees is the same as 0 radians, right? You already know what. So if you go that far, 90, that's 90 degrees. You already know that's pi halves, right? Yeah. And then which is 0.5 pi. Sometimes it's useful to think in terms of decimal. If you go halfway around, you already know that that's 1 pi. And sometimes it's even useful to turn that into a decimal, so like 3.14, right? And then 0.5 pi would be like 1.5-ish, somewhere in there. And then if you go 3/4 of the way around, if that's your angle, what would that would be 3 pi over 2, right? Or 1.5 pi. And then all the way around is, of course, 2 pi, which it's coterminal with these guys, but it's not equal. Right? 2 pi would be 360. 360, so there's 180. And that 3 pi over 2, or 1.5 pi, is the 270. It's going to be handy just to know these. And then if you think about it, 4 pi over 3, 4 pi over 3. Well, 4 pi over 3, 4/3 pi, 4/3 is a little bit bigger than 1, isn't it? So if 180 is 1 pi, then 4/3 pi, so that's the same as w of 4/3 times pi, 4 pi over 3. This is just a little bit bigger than 1. That's going to put you in the third quadrant, isn't it? That took a long time to explain, longer than it took me to convert, but once you get used to it, you do it very quickly. So you don't have to convert to degrees every time you want to think about, oh, which quadrant is this thing in? Okay, so the reason I want to know which quadrant it's in, remember, is because 4 pi over 3, we can not only think of it as an angle, but as an arc length. And the output of the wrapping function, which is what we're asked to find here, then has to be, its endpoint has to be in the third quadrant, because 4 pi over 3 is going to be a little bit bigger than pi. The input's a little bit bigger than pi. So that's how I know I'm in the third quadrant. But it's not 4/3 is not 1.5, is it? So I know I've got my endpoint, which is my output to my wrapping function. Whoops. I know I've got that right here. All I need to do is figure out the coordinates of this point, and that's going to be the output that I want for that input of 4 pi thirds. Does everybody understand? It takes me a while to explain this because it's so different from what you're used to, but does it make sense? Okay, so how do we figure out the coordinates of that point? And by the way, this problem is the key to figuring out how we extend the definitions of the 6 trig functions to real numbers. Well, the idea is we use what we already know about trigonometry to find the coordinates of this point. We already know a lot. You may not know it, but you know a lot. You know enough to do this. So if we go back to thinking in terms of an angle, then, okay, if this arc length is 4 pi thirds, since we're on the unit circle here, this angle here, let me use a different color. This angle here, let me stop it. So that when I draw this line, I go through, oh, I didn't quite make it, did I? Darn it. So that when I draw this line from the origin to that point, I go through that point so that this angle is also 4 pi thirds. There is that correspondence. This arc length matches this angle that this point is at from the origin, okay? And then if I don't drop a perpendicular, but I raise a perpendicular from that point where this line from the origin crosses the unit circle, I can create a right triangle and use what I know about trigonometry to get the coordinates of that point, which would be the output to the wrapping function. So, long story short, focus on this triangle here. I'll draw it in yellow. Does that show up? Yeah. So this triangle here is what we're focusing on. And I claim I can locate the coordinates of this point using what I know about that triangle. First of all, what's the hypotenuse? It's 1. The hypotenuse on that triangle has length, well, it's 1 because it corresponds exactly with the radius of the circle. I'm not talking about this extra length I drew over here. In fact, if you wanted to, we could erase that so that it doesn't confuse at all. All right, cool. So I know the hypotenuse is 1. Oh, wait, I know the angle here is 4 pi thirds. But if the angle is 4 pi thirds here, what's the reference angle? If the big angle is 4 pi thirds here, what's the reference angle? 60 degrees. Have you noticed that it's actually easier to get the reference angle in radians than in degrees? If you have an angle, unless I'm trying to fool you, if you have an angle measure like 4 pi thirds or 2 pi thirds, if you have a pi and a division by 3 in it, the reference angle is going to be pi thirds. So the reference angle is 4 pi thirds. How do you get it more formally? If it's in the third quadrant, so you're looking, does everybody understand what the reference angle is? So the reference angle would be this smaller angle between the x-axis and that terminal side of the triangle. So the more formal way to get it would be to take the 4 pi thirds minus the straight angle, which is pi. So we know what the answer is going to be. It's going to be pi thirds, but just to prove it to you, 4 pi thirds, the alpha, the reference angle is going to be the big angle. Think about it. The big angle is 4 pi thirds. The straight angle is pi. That gives you the leftover angle in green. 4 pi thirds, pi is 3 pi thirds to get a common denominator. So pi is 3 pi thirds, and when you do the subtraction, you keep the common denominator, and the numerator is 4 pi minus 3 pi, or just pi. But again, that's not how I get it normally. If I see 4 pi thirds, I know the reference angle is just cut out the 4, it's pi thirds. So let me blow this picture up so you can see what I'm talking about here. So I know this angle. I have to keep in mind which quadrant I'm in. This is quadrant 3. But this reference angle here is pi thirds. I know that this length here is 1. I need to know the horizontal side would be the x-coordinate. Think about it. This point has coordinates x, y. The horizontal side here would be the x-coordinate, or adjacent side of that triangle. Right? Now you have to keep in mind it has a negative, it's a negative number because you're in the third quadrant, right? So you have to make that adjustment at the end. Both these, the x and the y, have to be negative because you're in the third quadrant. Okay, and then what's this length? Oh, that's going to be, well, a directed length. It's going to be y, right? That's going to be a negative value as well. Oh, okay. Huh. Just use right triangle trigonometry, right? I don't have to put a negative in front of the y. It's a negative number. It's a directed length. The negative is included in the y. Well, it depends on how you look at it. If you're just looking at the triangle not coordinatized, then it's not clear that it's negative. But if you look at this picture, it's clear that it's a negative number. Okay. So I'm almost there. Stick with me a second. Okay. What then would be x? What? Don't even think in those terms. What trig function unites the pi thirds and the x? X is adjacent to pi thirds. Cosine, the ka part of SOHCAHTOA, CAH, right? So we'll deal with the negative in a second, but let's pretend like the negative's not there. What's the cosine of pi thirds? The cosine of pi thirds would be what? Adjacent, CAH. Adjacent over hypotenuse. I'm going to put that on the left side. X over 1. Oh, that's just X, isn't it? Now, that's if it's not coordinatized, right? We know it's coordinatized, so what do we have to do with that? We have to take the opposite of it, don't we? So because we're in the third quadrant, we know we're going to get a negative number. We have to take the opposite of it. So the x value of this point is the opposite of the cosine of pi thirds. What's the cosine of pi thirds? 1/2, so negative 1/2. If you take the opposite of it. How did she know that? Pi thirds is 60 degrees. What's the cosine of 60 degrees? It's one of those you have to memorize. Anyway, cosine of pi thirds is 1/2, so negative 1/2 has to be the x-coordinate of this point. What about the y? What trig function unites y and pi thirds? Sine. So the SO part of SOHCAHTOA. So what do we get here? If you're not thinking in terms of it being negative, the sine of pi thirds equals what? Y over 1. The SO part of SOHCAHTOA, sine equals opposite over hypotenuse, but what's the hypotenuse? 1. So we just get the y value. Y over 1 is just y. What's the sine of pi thirds? Root 3 over 2. But wait, we know that we're in the third quadrant here, so what do we have to stick in front of this? Negative. Negative. Okay, so the long story short, W of 4 pi thirds is negative 1/2 negative root 3 over 2. Students always look thrilled after they see all this work. Would you like to see the fast way to do it now? Okay. Well, the wrapping function, the coordinates of any point on the unit circle, then if you kind of generalize this idea from this example, W of t is always going to map to cosine of t, comma, sine of t. Always. If you'll see why from this example, why that has to be true. Let's do it for this example. What is t actually in this case? It's not pi thirds. What is t? It's actually 4 pi thirds. Pi thirds was the reference angle, right? So look, if you just take the cosine of 4 pi thirds, you get the negative 1/2 right away. If you just take the sine of 4 pi thirds, you get the negative root 3 over 2 right away. So anyway, when you see the cosine of 4 pi thirds, I want you to think, oh, the cosine of pi thirds, I have that memorized. Okay, that's 1/2. Which quadrant is 4 pi thirds in? The third quadrant. Remember from the video, all students take calculus, the mnemonic device? All students take calculus. All students take calculus. So which trig function, see for the fourth quadrant, which trig function is positive in the third quadrant, which is where 4 pi thirds is? Tangent, which means cosine is not positive there. So that's, so I take I take the cosine of the reference angle and stick a negative in front of it. Oh, that's exactly what I did over there. So anyway, you have memorized the cosine of 4 pi thirds is 1/2, and then you know from that mnemonic device, all students take calculus has to be negative. And also from the fact that it's in the third quadrant, any point has both coordinates negative in the third quadrant. And then sine of 4 pi thirds, the sine of pi thirds is radical 3 over 2, you have it memorized. And you're in the third quadrant, so you know it's negative. So negative radical 3 over 2. So this is how quick that problem actually is. Well, that's good news, right? It was getting pretty long there for a second.